So today's demonstration class, we are going to analyze some real-world data set. This is just to give you an overview of how SPSS is used. Yeah, so we're going to walk you through a real-world data set analysis, and throughout the demo lesson, we are going to see some of the things that we're going to touch. Of course, the demo lesson alone cannot show us everything that we are going to touch in the SPSS course. Yeah, because there are some particular statistical tests that can only be used for specific data sets. So if this data set does not fit that criterion, we will not be able to use this data set for that. We will not be able to use those particular statistical tests for this data set. But notwithstanding, you are still going to have an overview of how it is used. So you're all welcome to Earth Analytics. Our mission or our mandate or our objective is to create a data science world in Africa where every professional has the minimum knowledge and the minimum skills to be able to use data effectively to take informed decisions. So in that doing, we organize classes from time to time, and we teach software like Excel, SPSS, Power BI. For this series, we began with Excel in the month of June, and so this is August, and we are taking SPSS. After this, we'll go on to Power BI, and then we may come back to Excel. So we also coach professionals on one-on-one. Those who have enrolled in our mentorship class, we also give them on one-on-one coaching and walk them through their own particular data sets in their profession or in their own field of study. We also work with organizations by preparing databases for them and analyzing their own data as well. Of course, we also work with businesses and help them to track their income, maybe from drafting of their registers to inputting of their data on Excel or online, and how they can use these results to make informed decisions. So you're welcome anytime to reaching out to us if you have any of these objectives. You want to meet any of these objectives and you are lagging, you are welcome to join us anytime. You can always write us on WhatsApp or can reach out to me. So particularly in this lesson, I'll be taking you people in Excel. The other team members, I don't know if some other team members have joined, where you get to meet the other team members. Some are accountants, some are MIA officers. Okay. So in the data analysis, the very first thing that you have to do is to be able to get the main objective of what you want to analyze. Before even getting to the data set, you need to know what you want to analyze. And that is why the first thing is to get the main objective of your study or of whatever survey, your whatever thing you want to do. You get the main objective and you get the specific objectives. If you're analyzing data for a student, you need to ask the student for their main objective and their specific objectives. This is what is going to guide you to choosing the particular statistical test. It's very important. So the data we have today, the main objective of the study is to assess the prevalence of intestinal parasitic infections and identify associated risk factors among HIV positive patients attending the Bamenda Regional Hospital. Like I said, this is a real world data set. This was carried out in 2022 by one of Earth Analytics students, whose name we will not mention because for confidentiality reasons. So, for those who are not in the health background, intestinal parasites are what we can call worms. Worms that infect people. Sometimes in some areas, they infect children more. So this person wanted to find out the level of worm infection, in layman's words, the level of worm infection, and to identify the risks of such infection among those who are living with HIV. I know in the humanitarian sector or in the more professional way, we say those living with HIV, not HIV positive patients, but this is how the TP was crafted. So just follow it. And the Bamenda Regional Hospital is one of the is like the referral hospital in one of the Cameroon's towns, the Bamenda town. Each town or each region in Cameroon has a regional hospital built by the government for the population. So this is one of the biggest hospitals in the Bamenda region in Cameroon. For those who are not Cameroonians. So that's the first thing. So as data analyst, you already situate yourself somewhere. Once you read this main objective, the first thing is you situate yourself somewhere. So you already look at your mind is already tilted towards the health, intestinal parasites, and then you already foresee the location and the subject. The subject under investigation here, they are those living with HIV. Which, if you want to situate this in terms of research classification, this should be a cohort because these are people who have something in common. And what they have in common is that they are those living with HIV. All right. Although it was a cross-sectional study because it was done at a particular time, just a snapshot of that population. All right. So now you go deeper. What are the specific objectives of this student or of this research or of this analysis? What we want to know. So the student has broken them down into three to determine the prevalence of intestinal parasite. That's the first thing. So by the time you see the word prevalence as a data analyst, you already know what you will do to get this prevalence. That's the first thing you will do once you want to answer these objectives. Of course, when you begin analyzing data, you have to check for missing values and you have to always do the social demographic characteristic. That one is standard. You must do that one. But then when you want to answer the objective, you should already know what you will do to get what the prevalence. The second objective is to assess the relationship. One starts to see what's like relationship, association. When you start seeing what's like this, significant relationship, you already start thinking of what inferential statistics, which means things like p-value must appear here. So once you see to assess the relationship between risk factors and intestinal parasitic infections among that population, you're already thinking of the various tests that come in under what inferential statistics. Now, they have talked about risk factors. So you are looking forward to seeing risk factors in the student's questionnaire. That's how professional analysts work. If you don't see some things that they want to measure in their questionnaire, then there's a question mark somewhere. So you expect to see a variable that captures the result of parasitic infections, because that's our specific objective one. We expect to see some risk factors being measured in the questionnaire or in the survey or whatever thing you're working on. And the last thing is to evaluate. So you always hear words. These are very, I mean, I can call them the keywords. These are the keywords in data analysis. You hear, or in data science, you hear words like to assess, to evaluate, to determine, to measure. You hear when you start getting words like that, just start thinking of inferential statistics. So the third is to evaluate the association. So you now have two keywords coming together. Evaluate and then association. When you see this word, you can underline them as an analyst. So this will guide you. So to evaluate and to associate, to evaluate the association between ART, that's antiretroviral therapy. For those who are in the medical health, these are the medication that are always given to those living with HIV, antiretroviral drugs or antiretroviral therapy. So this participant wants to, or this student wants to evaluate the association between ART treatment or ART treatment characteristics and intestinal parasitic infections. So like maybe those who are taking their drugs regularly, do they have a low level of the infection or do they not have it at all? While those who are not regular with their medication, are they more prone to having this infection? So once you read these objectives and understand them, you already situate yourself or in the context of this research and you start thinking like the student or like the researcher. So you're now part of the research team. And this is what actually gives the analysis joy. This is what I like because each time you situate yourself or you find yourself being part of the research team, you are uncovering information that is not known. You are contributing a lot to the world. Just imagine that you are able to find out from this research that those who are not stringent on their antiretroviral therapy are more prone to having infections or parasitic infections. It's going to go a long way to help people or to help the government to sensitize the population on the importance of what adhering to their treatment. All right, so the first thing you do is that you go through the objectives as we have done, and then you go to the questionnaire. So you ask three things: the objectives, the questionnaire, or the research tool, as some analysts will call, or some researchers will call it, the research tool, which is the questionnaire, and the data. So we have seen the objective. Now, when you go to the questionnaire, we want to see questions that test all these objectives. If you don't see some, because some students will do this and they'll go astray in the research tool. So as an analyst, you should be able to ask questions. Do these questions on the questionnaire actually answer the specific objectives? If not, then you may have to pause a little bit and discuss with that student. Sometimes when I'm working with students, I will tell them that if I began working with you in the beginning, I would have modified your research, because you see the students testing something in their objective, having specific objectives, and in their data, they're collecting data for something else, or they're collecting what they don't even need. All right, so we are going to look at the questionnaire and see if it actually answers these objectives. All right, so I'm sharing that. So for our demo one, this is the questionnaire. Like I said, I'll remove the name of the school because this is strictly real world data. As we said, in Earth Analytics, we are going to be working with real world data. We have a whole database of real world data, and the students that work with us, the original that we can use their data to teach others to increase knowledge. Yeah, only that we don't have to disclose their names. For some, we will disclose their names based on their consent. So this student was a master's student in medical laboratory science or laboratory medicine. And this is the research topic: intestinal parasitic infection and determinant factors among HIV positive patients attending the Birmingham Regional Hospital. And this is the questionnaire, section one. We have the demographic data, which you must always collect. You don't need to go and put in your data, in your specific objectives, that you're going to test male and female. Oh, no, we already know that in every research, we need to know who your participants are, or who the population that the population in question is. So we expect to see gender or sex. That's the real word. That's even the correct word. It's sex, because either you're male or female. Because when you put gender, you need to start talking about other things like transgender, all those other things. But most often people think that gender and sex are the same thing. So we have the age, and the student has already stratified or grouped the age here: 10 years below, 11 to 30 years, 30 years and above. Working status: are you a worker? Do you work? Like, are you employed? I think that should be the best word to have been used here. Are you employed, or you're not employed? Or are you a student? Maybe she was interested in students in something. We don't know. If not, it should have just been, are you employed or you're not employed? That would have been perfect. Are you from marital status? Yeah, single or married, or maybe you could have added divorce, because that's also a status. Um, or sometimes in the recent words, we don't even use the word single. We use never been married. I have never been married. Is more professional than single. All right. So level of education. I think it should be primary, secondary, and tertiary. Although I can see things there like first school. Sometimes if you're working as a lecturer, I think some of us here are lecturing in the university, you should be able to review some of these things. So you see that we have seen the demographic characteristics, and we are now seeing the risk factors. So she has risk factors, like, so she considers wages, like those who are working, to have uh to be a risk factor. Maybe those who earn very, very low salaries are more at risk. We don't know. We'll find out. Then she has location. Maybe she's interested in where people live. Like, you have areas in Bamenda like Mancon, Queen, Upstation. Those who have lived there, they know these things. Maybe the researcher wanted to know if particular zones, people who live in particular zones, maybe there are areas that are filled with, maybe there's more, it's more close to the dumping side for dirt, the garbage side, or maybe the drainage is common, maybe a poorer area. I don't know, but person looking at this type of water they use or they consume. I think it should be mineral water, not well tap. It's okay, depending on the location or the language used. Well water, spring, when last did you deworm? The ART treatment, start date, patient regimen, does the patient have a type of co-infection, viral load, So you can see very well here that the student has captured the risk factors. And you should also know as a researcher that these demographic characteristics are the first risk factors, by the way. The first risk factors. Just for that you are a female, you are more prone to some things than male. We all know this. Just the fact that you are young, youth, elderly, they are more prone to some sicknesses, some diseases. So these ones alone, they're already risk factors. Even working status, those who are unemployed. So those who are unemployed, yeah, so you understand. I think we have understood. But I have not seen a question here for the results. Have you seen? I've not seen a question here for results. So doesn't mean that there was no result in this questionnaire. At least I should see maybe question 18, the result of the test, because they should have collected their samples, right? Maybe there's 2 samples or something to check if they actually have that infection. All right, notwithstanding, we are going to check the data and see if we'll see results. If we don't see results, we have to get back to the researcher and ask questions. Okay. All right. So the next thing we have to look at is their data. And that you can always get the data and enter it yourself. You can always get the data and put it in yourself in Excel. But if you grow in data analysis and have much work, you will not be able to do that. So what I do is that I usually coach my researchers how to key in their data onto Excel. Because that's a software that if you have a computer, you should have it. Not everyone has SPSS. So I'll tell them to key the data onto Excel, and then I'll get it from there. So you can already see here that the data has already been coded. Yeah. So you just, when you see age range, at least you can even understand that gender here, M stands for male and F stands for female. But then you see the other things, age range, you're just seeing numbers 2, 1, 2, 1, 2, 1, 2. Like if you're not used to, you see 1, 2, 3, you just see numbers. What's this? It's funny, right? But this is what we call recording in progress. This is what we call coded data. So data has been coded already. So in this SPSS course, we're going to teach you how to code data. But then when your student codes their data, they're supposed to tell you what the codes mean. Because when you get into SPSS, you have to tell SPSS that this tool like this, it means this. Because the software does not automatically understand that this tool means maybe an age range. I don't know what the age range is unless we see the codes. Okay. So you have to work with your student. You in the course, we'll teach you how to do data coding. It's very easy. Very easy. It saves time, Now, when I look at this gender here, the student has just use letters as the code. But as an analyst, I know that SPSS is smarter when working with numbers than with strings. And I know that there are some statistical tests that will not work with strings. What am I saying a string? A string is a data type. For example, this text you see here, this is text, right? MO, these are letters, it's text. So when you get to SPSS, you have what we call data types. As we did those who attended the Excel course, we did data types, right? So SPSS also work. In fact, data, if you are as an analyst, you are supposed to be versed with data types because you're going to work with it. You have dates, you have strings, you have numbers, numerical values, and all that. So this one, although it is looking very nice like this, there's some tests that cannot work If I don't convert this, I'll convert this to 1 and 2 or 0 and 1. I'll convert it. But when I'll go to my software at the back end, I'll tell my software that this 1 means male and this 2 means female. All right, let's look at the codes. Or let's just flip through to see if we'll see results, because we didn't see it on the questionnaire. If we don't see result, then we'll ask questions. You can see ART, all what we saw on the questionnaire, they are here, viral load, toilet used. All right, now I see result. Right, okay, that's fine. I see result and I see some names here I don't understand. So what are these names? What is this? His? What is this? So you can ask the researcher what this mean. Maybe these are the type, maybe she went or he went further to classify the type of worms that they saw. Maybe you can ask them, and then what do they need it for? Because we didn't see this in their specific objectives, right? We did not see anything like to determine the various type of intestinal. We didn't see that. That's why sometimes I'll have an argument with my students, like this wasn't on your objective. Why do you want to test it? Because if they wanted to go far, they would have told us that to assess the different types of intestinal parasites, but we didn't see that in the specific objectives. So if it's good and they want it, they can add it, but we didn't see this. All right, but we have result. But then what are these ones? Because the student has done the coding and should normally show us the codes, because you're not a magician to know that these two means something. So on the next sheet of the Excel file, we have the codes defined. You click on it, and these are all the variables we saw. I'm calling another word variable. If I'm not used to it, if I've not heard the word before, I don't know what it means. Don't worry. In this essay, in this course, we are going to teach you all of that. So all these columns you see, gender, age range, these are called variables. Okay. So you see that all the variables now are on column A. All of the variables are here. And then we have the code and we have the description. So the one I am seeing under age range means 11 to 30 years. And the two I am seeing means more than 30 years, or those who are above 30. The working status, the one I am seeing here, means it's a worker. And the two I am seeing means that the person is not working. And if I see 3, it means it's a student. You see, so every number on the code has been defined or is described here. As you can all see that. So this is the third rule I'm telling, right? I've given the first rule is that you must get the objective. The second rule of thumb is that you must get the questionnaire or whatever the research tool. Then the third rule of thumb is that you must get the data. And if it's coded, you must get the course must be defined, well defined. So you flip through and check. Flip through and check. This one has been carefully organized, but in the real world, because I have worked on this data and carefully adjusted it, sometimes the data will not come in organized like this. Will come in something very close like this. You see this, right? Those of us who have seen data, it comes in so tattered. So as an analyst, you just organize it to look good for you. You see. All right. So that's the fourth thing that you do. Once you have checked this and it's okay, I can come back now and change this, because I already know that it's best working with numbers in a machine, binary numbers. For those of us did ICT in the elementary level, you know that even the what is the motherboard itself, or the CPU or what, it works on zeros and ones. So I will just highlight this. Those of us who did Excel, I think now you now see why we have to begin with Excel, because it is now I will just be doing things and be going. I will not be explaining to you that I want to highlight this column and then there's a shortcut to highlight the entire column. Those of you who enroll in the Excel course, you already know this. For those of you who do not enroll or who are not opportune to join the Excel course, what I did was that I just click on this first one. Because if you have up to 500 rows, will you click like this and be dragging it down? That will take a lot of time. So you just click on the first cell, you hold the Control and the Shift key, and then you click the down arrow. If there was no gap in between, there was no missing data in between, it will take you to the last one. So you can see that there are 102 participants in this study. So you should also take note of the number of participants and compare with what the student has written, maybe in their protocol or something, or the researcher. I keep using the word student because we work a lot with students. Okay, so I will just do this. When I highlight, I will just take Control F, then I click on replace. Then I want to replace that letter M with 1. I write 1. When I began analyzing data, I did not know some of these functions. So I'll be doing this manually. Imagine doing this manually. It will take 24 hours just to analyze or to clean your data, right? So I will place F now with 2 and everything is replaced. Now those codes are not here. I can come in here and I add the code myself. I'll just add rows above. I think those of us who are versed with Excel, you already know how to add rows above. I just add a few rows above for that one, maybe 3 rows. Then I'll say gender. That's 2 code. 1, because you may think that you have put it in your head and then you forget. 1 is male and 2 is female. Okay. So we can onboard it since they are not headings. All right, then we save. So that's the fourth thing that you do. Once you've checked all of this, you will get to SPSS and you import this data into SPSS. Okay, so that's the next thing we are going to do. That's the next thing we are going to do. Import the data to SPSS. Okay. Oh, is it going? Mr. Shea, Karen, are you learning?
Yeah, going.
Okay. All right.
Yes,
So
it's going. I'm following up.
all right. Okay. So let me launch my SPSS, our version 26. And we'll be sharing this to those who do not have SPSS installed in their computers or those who have earlier versions. If you have any version less than 26, we'll still give you this. For those who will enroll, we'll share this to you and they will show you how to install. We'll send a video on how to install it. Okay. So this is my SPSS window. I hope you can see my screen. This is the SPSS window. So we're going to explain all of this to you in the course because you have the data view and you have the variable view in the SPSS window. So I'll go to the data view because I want to import the data. And the easiest way to import my data is I'll go to File and I'll take Open. You can still come to import, that's fine. But I prefer to take Open. So I go right to take data. I want to open data. And now you see these files of type here. Files of types, it says SPSS. So if the data set was already inputted into SPSS, you should automatically see it in the folder where you want to put this. For example, if I use this arrow up here, I can navigate to all the folders in my computer. Okay, so you have to choose the folder where you have saved the data. So this data has been saved in a folder called Earth Analytics SPSS course. So I can take this PC, I take Open, then Windows, Open. You have to search where you've saved it. Then it's Earth Projects, and then it's Earth Analytics. See there. Open it, and then I think that's business. Yeah, here, and then we have the Excel course. When I open it, I say okay, I see demo. This demo 1. I open demo 1 and I see instead this is a file that is present in demo 1, but it's not what we want to open. Because what we want to open is an Excel file. And this is the first mistake that most of my students always make. They are saying here that what the software thinks that it should open is an SPSS file, but you want it to open an Excel file. Then when you don't see it here, you say you have not seen your data, it's missing or things like that. So the simple thing to do is to come here and change this data type here, this file type rather, to Excel. Yes, change it to Excel. Once you change to Excel, all the Excel files in your folder will pop up. So we have the Excel, we have the data here for the demo 1. Click on it and you take open. And then you watch SPSS importing it for you. And SPSS says that read variable names from first row of data. I'm sure we already understand this, right? Because the first row, what we call the column names or column headings in Excel, do they contain your variable headings? If yes, then you allow this one checked. Percentage of values that determine data type. So SPSS wants to automatically determine the data type for you. And it's asking you that if I say up to 95% of data, maybe in text format, then I will call this data text. Okay, do you accept that? Say yes, you can take it to 100, but I think 95 is ideal here. Ignore hidden rows and columns. You know, you are using Excel. Maybe you are hidden some rows and columns in Excel. And it's saying that should they ignore them? Which is, of course, I think it makes sense because you may have hidden them because you don't need them. But if you don't allow this checked, SPSS will import all those hidden rows and columns. All right. So you'll allow it checked. Remove leading spaces from string values. This one you don't need to remove leading spaces. All right. So remove trailing spaces from string values. This is spaces after the string values. If you want, you can remove them, but I think I always like to leave it like that. And if your data is present in sheet 1 and sheet 2, you'll see the variable sheet here. You see, if I click on this drop down here, you'll see that there was a sheet called codes define. It's also there. So your data can be in sheet number 10. You just need to come here and choose that particular sheet and take, okay, so our data is in sheet 1 and that sheet 1 is called data. So we allow it like that and we import our data into SPSS. Okay. It says screen sharing has stopped. Let me share the screen again. I hope you can see that. All right. So this is our data in SPSS. It's similar to Excel, right? We have columns, we have rows. But now the difference here is that the rows in SPSS begin with 1 and it's actually 1. But in SPSS, this 1 is up here. Sorry, in Excel, this 1 is up here. That is why I prefer to number my questionnaires in Excel from 1 right downward. Because in Excel, row number 14 in Excel is not data number 14. Maybe yours will be number 15 because the Excel numbering begin right up here, but SPSS begin down. So once I have imported my data to SPSS, this serial number column becomes useless because this one already works, that does that work for me, this other one here. So what I simply do is that I cut this one off. And then in SPSS, once you click the column name, the entire column now is variable. In Excel, we call it column, but now we call them variables in SPSS. Once you click the variable name, the entire variable is highlighted, and I can just right click and I take cut. I don't want to delete, or I just cut it. I don't know. I'll never paste it somewhere, so it's gone. Which means my data now begins with gender. Now, when we go to the course, by the time you see this symbol here, you already know what data type this represents. I think all of them actually are the same because that is all nominal. Yeah, there's no scale here. You see those ones that do not have anything now. These are missing values. So once you see a dot in SPSS like this, it's a missing value because the students did not input anything on this says. He just went and inputted maybe 1 means positive. Maybe this person had this particular type of intestinal parasite or something. But that's not our concern because it's not in a specific objectives, unless you have to go to the student and then you discuss more with the researcher. All right, so this is it. I've imported it into SPSS and then it's 102. That's confirmed. Now, the next magic that you have to do is that you have to tell SPSS what this 1 and 2 mean because it doesn't know. If you go and analyze this data, what it will give you is what we call rubbish in, rubbish out. It will give you that this 1 appears maybe 20 times, maybe this 2 appear 40 times. It will give you that. But until you tell it that this 1 means male and this 2 means female, it will still be rubbish in, rubbish out. And where do you do that? You do that under variable view. So you click on variable view. Once you're on variable view, you see all those names. They now appear on one, let's say one column here, just like they appeared in SPSS page 2. where we had those quotes. All those names appeared like this. So you can even increase the size to see it very well. You can do that. And when you see very well that SPSS does not need the name, the variable name in SPSS does not require you to put space. Can you notice that? Look at age range. There's no space between age and range, but there was space between age and range in Excel, right? So this particular variable name here, you don't need it. And then for some people, they'll not even name this as, they'll not call these variable names. They'll call it maybe question 1A, question 1B. If it's section 1, section 1A, 1B, 1C, 1D, then when it comes to those risk factors, they'll begin to say 2A, 2B, 2C. And then when they'll come to this label you see here, and then they'll write the real names. So if you have ever seen that somewhere, it's still correct. But as for me, I always prefer to leave it like this, because sometimes you will need this in some analysis. You will show by these names in some statistical test. But if you're going to use 1A, 1B, 2A, how will you know that this 1A means, right? You may have to come back to check it. So SPSS has tried to label some of this for me, but it's not that smart that it can label all. Okay. So he has not labeled this one because maybe he's not understand. So I will just complete it for SPSS. So this is gender. This one can take space because it's the label. I'll just complete this one. We just complete wages, location, treatment, results. This one I can leave it because I don't need it. I can leave it because I don't need this one. After result, I don't need any of these things. All right. So you see that the data type here is string numeric because we changed everything to numbers. If you left that gender as M and F, what you will see here will be string. When you click it, you will see the other data types. You have comma, separated values, you have dot, you have scientific notation, you have date, you have dollar, you have customer currency. For those who are in finance and are using SPSS, you can have dollar sign or dollar data type. String, this string, you would have seen string if we didn't change that M and that F to 1 and 2. You would have seen string here. And the width is 1. If you want to increase it, you can increase it, but I can always increase it by dragging the thing, dragging the width right. Okay. So I double click on it and you can change it. Okay, so I'm reducing it here. Can increase it here. All right. So right here you can increase the width. When you're increasing it, is not showing here. This is just like your back end, right? Those who have done software development, this is your back end. When you do anything here, it will appear on the data view. Okay. So let me click the data view, and you'll see that gender, the width of that gender will be bigger than any other one. Or is the same? Okay. Normally it should increase here. But that's not a big deal. Not our point of concern. You can always drag it. If it is too small, you can drag it left and right, like here. You can always increase it, you see, just like Excel. All right, the next thing is the decimal points. Since this data is the nominal, it doesn't have decimal points, right? Because we have given codes to it. For some data types, you don't need to code them. You'll see that when we begin the course. Data type that some measurements were done. Maybe the patient's weight was taken, for example, in kilograms, and it was not categorized into different categories like maybe underweight, obesity, overweight, obesity, normal weight. If it was not categorized and it was just inputted like that, then you can have maybe somebody would take 35.5 kg. You understand? So with that kind of data, you need to come in and increase decimal points to 1 because the data has decimal points, right? If not, leave it at 0. Then then the label. The label here we have seen it is the explanation of the variable name, which for me is the same thing. But if you have chosen to put Q1, Q2, or 1A, 1B here, then you will give the names here in this under this label. Then where the magic will actually function, which most people don't know, is these values here. This value here is when you're going to tell SPSS what those codes mean. Okay, so you do this one manually. So when I click on it, it says value. The first value, I'm under gender. Okay, as you can see, we're on gender. So the first thing we do is value is 1. And what's the label of that one? Is male. We did it right. We changed all the M's to 1 and all the F's to 2, right? So we must bring it back here. So this is like the back end. It's about we're telling SPSS in the back end that this 2, it means female, right? Yeah. And then you take okay. You have put the label. The age range. How do you get the codes? You go back to the Excel sheet and go to where the codes were defined and look at the age range. So we have 1 and 2. But is it 1 and 2? Because of the age range, I see just right is 1 and 2. But there were 3 in the questionnaire. Maybe one of them, there was nobody that was in that age group, so it was entirely eliminated. So 1 is 11 to 30 years, and 2 is 30 and above, or above 30. So for age range, I'll come. No, that's not age range. Age range, I come here. 1 is 11 to 30 years. Why the student chose to use 11 to 30 is, I don't know, but maybe based on their research, they chose to use it. But you know that in classification, this doesn't really work because you have to look at adolescents, adults, the late 40s and things like that. So greater than 30 years. All right. So this is how you do it. You fill all of this. When you fill, you take add, then you take okay, you go to the next. So this way you fill all the codes except for variables that don't need code. Those ones you don't need to put any value here because they already have their values. Like I give an example of weight. If it was not categorized, it means it already comes with its values. So you don't have to fill any values for it here. And its own data type or its own measure here will change. So all the measures here you see nominal, right? I think you are here, right? All the measures here you see nominal, which means we're working with categorical data because we have categorized all of those things: gender, male and female, age group, less than 11 to 30, greater than 30, we've categorized. We put all of them in categories. So if there was a particular data or variable that was not categorized, maybe this would have changed, maybe to scale, right? And then one other variable that ordinal means it is ranked, like those in maybe for those codes you gave, those whom you gave the code to are in a higher ranking than those whom you gave the code 1. For example, level of education. I always take that as a very good example. Level of education, those who are in the primary level of education, those who are in the secondary level are at the rank higher than those who are in the primary level of education because they spend more time in school. Sometimes I used to explain this to my students and they don't really understand. They'll tell me that even sometimes in our African culture, they say men rank higher than women, but that's gender bias, which doesn't work anymore. For male and female, it is not ordinal, it is nominal. But for level, somebody's mic is on. Can you mute your mic? Okay, so I think we understand why I want to change this. For level of education, I want to change it to ordinal. Ordinary means it is ordered. Okay, it's not it doesn't mean that it's ordinary, but it comes from the word order. So it's ordered in ranks like 1, 2, 3. So this one is very important. Even when you're doing Likert scale, those of you know what Likert scale is, we'll see all of this in the course. Likert scale, you choose this because somebody who has a score of 3 ranks more than somebody who has a score of 2. So that's how you do it. And then this role here is just the role that is being played by the variable. Like, we talk about what? Dependent variable and independent variable. We'll see all of that in the course. So if your variable is an independent variable, then it's an input because they have a role that they have their input because their work define the main variable. Recording it. Okay, so the main variable here, the variable of interest here is this result, not so. because everything is centered around intestinal parasitic infection. So that is our variable of interest here, which means it's our what? This our dependent variable. It means all the other, it depends on all the other variables. And this thing is what sometimes, so in this case, you choose target. Is our target variable or our dependent variable. So sometimes people get to confuse between dependent and independent, students don't really understand or analysts don't really understand. But it's so simple. Why? Because without all the risk factors that we have mentioned, would there be any parasitic infection? I don't think so. If there was no risk factor, there was no warm, there was no dirty water used, there was no HIV infection, and all of those things, there will be no result. There will be nothing like intestinal parasite because there's nothing that favors their growth. Let me put it this way. So it means that this result of this parasite, it is dependent on other things for it to exist. Other things must exist. For it to come to pass, there must be maybe gender, male or female. There must be maybe use of dirty water, maybe use of pit toilet or things like that. So this variable is a dependent variable. It means it depends on all the other variables. That's so simple. I think that if somebody was confused on this, you've understood now. All right, so what I'll do is that I am going to, since we don't have enough time, we cannot spend the whole time putting all these values here. So I'll just import the data set that I already inputted, and we'll see one or two tests, and then we'll take a few questions, and that'll be used for our demo class, and then we'll meet again and then we'll give the modalities for our SPSS course. Then we'll see how it goes. All right, so let me stop sharing this one. And then I share the other one. So some members of Edge Analytics have joined. We'll soon have the opportunity to meet them, some of our team members. And as we roll on with the course, they will be coming in once in a while to share their story. Maybe their story can motivate or give you more reason to keep on. Okay. Did somebody write me? Okay, we are following. Okay, that's great. Okay, so here we are. Let me share that one. It's the same data, but I already inputted all the values for us. So let me share it now. Okay, I think you can see that clearly. Right, so it's the same thing. Variable view, you can see we feed everything. And this is the result. 1 means positive and 2 means negative. So and as an analyst, you are going to take a lot of time to clean your data. This is part of data cleaning. They always say that 70% of our analyst time is used in data cleaning. Sometimes most analysts just really want to go and click analyze. But if you don't properly clean your data, you're going to have issues. You analyze your data, and at the end of the day, you have to repeat it, which is very painful. So now, what is the proof that you have put those codes? When we come back to data view, you still see the 1 and 2 that were there. But what's the proof that you inputted those codes? It's when you come to this place. Let me show you. Do you see this thing here? Value labels, where my cursor is. Where you have 1, then you have this arrow pointing up to A. If you click on it, and the data has values that have been labeled, you'll see by those labels. I'm saying this because tomorrow some of you will be teachers, and you will give an exercise to students to do labels, and you don't need to come each time, click on variable view to check. You simply just come to this particular tool here and you click on it. Did you notice what happened? Once you click on it, you see all those labels. So this is almost like the raw data. If you were inputting this data in SPSS, in Excel, by typing, this is what you will have. But it will not be this perfect because you will type with errors. You type married, maybe a married spelling, you know, put R in one spelling. You start another spelling with small letter MO. That's why I don't like students inputting data by typing, because it will give me a lot of work. They should use coding. All right. So once you click on it, you see all of it. And it's even looking so cumbersome. But once you click back on it, it goes back to the code, which is even easier to work with. Even your brain sees this one and it's alert. It's like the freshman says, when your brain sees this one and two, it's not too crowded. So your brain is like, we can handle this. But once you see this much like this, oh, your brain is like, can we do this? All right. So that's the first thing you do. And now the next thing you do is you don't rush to analysis. You check if there are missing values in your data. And if there are missing values, there's a way to handle missing values, which we'll see in the course. By the way, what are missing values? We'll see all of that in the course. I'll show you missing values, right? Missing values are simply the conditions or situations where there was no data. Like maybe the participant did not answer working status. What will you do? It means it will be empty. All right. So you come to analyze. And I think you have missing value somewhere. This is okay. Analyze. Do you see this? Missing value analysis. That's the first thing you do. Click on it. Now you see they're asking if you have quantitative variables and you have categorical variables. So you need to know what variables are. Because if you don't know which variables to put on a quantitative, which to put on a categorical. But all our variables are categorical variables. So I just click inside this box. Then I take Control A to highlight all of it. And I bring it here. I use arrow and send it here. I just take OK. I don't need to go to many things. I just take OK. Once you take OK, I think SPSS has given me a new screen, which we are not seeing. Let me share the output screen. Now, this is the output screen. Once you take OK, SPSS gives you a univariate statistics and statistical analysis of all the variables in your data sets, the number of the sample size or the number of data, distinct data type, data in each row or each variable. It gives you the count of missing values and the percentage of missing values. So you see that the variable gender has the 102 participants and there's no missing value there because it's 0 here. Okay. And you just scroll through to look. Now, when it comes to that thing I was showing you guys, that those names that they were giving us, his or something, you will see that just 2 of them were labeled here and 100 are missing. And it gives us 98% of missing values. Can you see? I'm sure it's very clear now, right? So once you have more than 5% of missing values in your data set, you need to do something with it. And I'm going to show you how to do that in the course. Because once you already have more than 5%, and if you leave it empty, you'll skew your data. It's what we call skewness and kurtosis. All of those terms, we're going to see them. But especially when we're working with quantitative data and inferential statistics, we'll hear all of those words. Normality, test of normality, skewness. The data is skewed. He has done this. Yeah. But most often, if you're here and you want to learn SPSS for humanitarian work, you may not use that type of one because you might end up just with categorical data because you're using surveys and you mostly have questions and multiple choice answers for participants to choose to give their choice. And even in areas where participants have to state their own opinion, that one is qualitative data where you only have to do summaries. And if you want to analyze it, you may have to use a different software like NVivo because SPSS does not analyze qualitative data. Yeah. All right, so the next thing we're going to do is, let me go back to our data set. So we're rounding up. So the next thing you do, you have already seen that your data is good, right? We don't need those other those other variables that had 98% missing values. We don't need them because they're not part of our objectives. But in case we needed them, then we will not need to know what to do with them, right? All right. So the next thing you have to do is you have to do with your descriptive statistics for what the socio-demographic characteristics, whether it is in the objective or not. We need to know who your participants are, where they come from, their age range, their age groups. Are they married? Their social characteristics. We don't need to know their names, but we need to know something about their demography and their social life or their social characteristics. So when it comes to all of these things, we're going to see most often, most analysts know just analyze in SPSS, analyze. But one very important tool here is this transform. I'm going to say it is very important. Even this data, but not that big deal. But here is also important. If you want to define some things, it's very, very important because sometimes, for example, in this data set, right, we have male and female also. Maybe a particular researcher may be interested only in females that are living with HIV. And you want to test all of these things. If they are prone to intestinal parasite or not. So if that particular researcher wants to work only with females, what do you do with these males here? You don't go and be deleting everywhere you see one. You go and delete it one by one. Also, you spend the whole day. So there's a function in SPSS that you can go and strike off the males. Thing is under this data. Select cases. Yeah, we'll see it. You go and select only females. Once you do that, any other thing that you do on the data is only females that will appear. Only the results will be shown. Unless you come back. In fact, if you want to do this kind of one, make sure you duplicate your data and save the original one somewhere. Because you can do it and you're not able to go back to the original stage. All right, so we go to analyze and we take descriptive statistics and we take frequency tables. That's the cheapest now. Yes, SPSS is not difficult though. Anybody, and once you are clicking, you can click and have anything. Like I'll just send this gender age to the right. But the easier way is to click the first one, hold your shift key, and click where do these things end? I think they ended with location now. This social demographic in the questionnaire. So you see why the questionnaire was important for you to have it. This type of water came in under risk factors, right? So these ones are all the socio-demographic characteristics. You want to just get their frequencies to describe. That's the first thing you do. You just do this. And then I don't like plotting charts in SPSS. So I may not show you how to plot charts in SPSS. But you can have charts and if you can add charts here if you like, but their charts are not good from my own experience. So I plot my graphs in Excel. And that's why we began by teaching you Excel, so that some of these things we'll just copy to Excel and plot our graphs. With Excel, you have autonomy to change your colors, make very good, beautiful charts. So I just take OK for frequency tables, and let me share the output window because SPS always gives you a result in another window. So this is it here. And again, you see that the missing values there are no missing values. Still showing 0, 0. And it gives you what? Male and female. Do you now see male and female? But you were seeing 1 and 2, right? But now you see male and female because we labeled the variable. If you do not label it, you see here, you see it will be 1 and 2. And we don't know what 1 and 2 is. So there are 24 males giving us a percentage of 23.5%, and there are 78 females giving us a percentage of 76.5%. And altogether, we have 102 participants, which gives us 100%. If there were missing values, and depending on how we wanted to treat them, you may not count this percent here. You may instead count by valid percent. We'll show you in the course why you choose valid percent in some cases. In some cases, you will choose percent. So you see that SPS will not give you the results in one table. Like you see the result being presented in Microsoft Word. We'll just put one table, and on that table we'll have gender, we have their own percentages, we have age range on one table. But in SPSS, each variable is a table, as you can see, which means that you need to still have skills of transferring results to Microsoft Word for interpretation. So we are training data analysts, and we hope that someday you can be a software that will already interpret data for you. So that when you do like this, out of this, you can choose maybe to click a command and all this data will be organized for you in one table with already interpretation. Like Power BI is already going on. With Power BI, you can just ask questions sometimes, even just typing, and Power BI will give you answers. That's using AI in data analysis. So maybe someday SPSS will also reach that stage. Because with this now, you have to manually take this to Word, arrange it, and then you interpret it yourself, which is good because it makes you think. When you think, you grow. Because at least with the advent of AI, we have seen that there's research that was carried out in universities in England, and it was confirmed that those who use AI a lot, their reasoning faculty has dropped. That means they're becoming dull. In normal sense, when you overuse AI, you become dull. Your brain doesn't reason fast again, and that's dangerous. So let's use AI diligently. All right. All right. So we have this age group. We have all of that. Then the next objective was to assess. Let's go to that. To the objective. The first one was to determine the prevalence. Okay, prevalence. How do we get the prevalence? Prevalence, for those who don't know, is simply frequency table for that particular variable. As simple as that. And you choose to concentrate on what? The number of positive cases. All right. So let us do frequency table for results or result of parasitic infections. Okay. That will give us our specific objective one. So I'll come back to analyze. I'll take descriptive statistics, frequency table, and this was already done by us. So we'll simply reset this since we're bringing in a new variable that we want to do. So I'll simply click on reset. Then I'll bring in that result. Where is it? Is it result? Bring it and I take okay. When I do that, I see that 94 persons were positive. Interesting. That means 94 persons had at least one parasitic infection. That's terrible. And so what's the prevalence? The prevalence is 92.2%, as you can see, the number of positive. So if you interpret this, you say out of the 102 patients living with HIV that were tested or that enrolled in this study, 94 in bracket 92.2% were diagnosed positive of at least one parasite, one intestinal parasite. Okay. Then this one is best to present it on maybe a pie chart. So you can copy this result to Excel and plot a pie chart to further show the result to your audience. You know, the visuals attract us, they speak more than just tables and figures. So people are afraid of figures. When they see figures, they are scared. Once you put a data on charts, you know, some people find it very, very easy. Okay. All right. So the next thing was to assess what relationship between risk factors and intestinal parasitic infections. The second and the third, we have to use the same statistical test. So we'll just do the second and then we'll discuss, and that will be it for the demo lesson. So as an analyst, I already know that I will use chi-square because I already know the data type that I'm using. I'm working with categorical variables and I'm looking for association. So it's chi-square that I will use. And it's not just using, but knowing how to use the chi-square test. We'll see tests when we're doing, when in the course, we'll see many tests. We have the Mann-Whitney U test, we have the Wilcoxon test, we have T-test, we have ANOVA, we have logistic regression, we have multivariate regression, we have even survivor analysis, we have how to analyze the Likert scale, we have all of that. But you need to, and then we'll have to teach you that because it is by knowing those tests that you know which of them to use in which data. But the more popular is chi-square anyway. So at least you should know chi-square. If you forget all of them, you should not forget chi-square. All right, so go to analyze. You will not see chi-square in SPSS, unfortunately. You will never see anything they call chi-square. But there's a way to go to get it. Is when you look at what crosstabs. You go to crosstabs. Crosstab is not a type of test, but it will. But under crosstab, you will now see chi-square. All right. Can you see this screen? Maybe I'm sharing a different screen. I'm sure I'll show you a different screen. I don't know. Hope you can see the screen now. Because Zoom is now very powerful. When I share a different screen, it's like you Zoom my understanding. All right, so we're here, and I always like to put the dependent variable as column. I know why I do that, because when you copy this to Word, that's where they will be. When you copy this result to Word, normally you put your results, your positive and your negative as columns. Then on the rows, you're going to put your risk factors. So I'll start with the first risk factors, which are the socio-demographic characteristics, which begin with gender and take right up to, I think, location. Then I'll put it on the rows. Then I'll come to exact. Let's start with the first one. There's a reason why I'm doing this, because most analysts don't do it. I'll come to this exact. I'll choose Monte Carlo. I don't know if I'm pronouncing it very well, but I'll not leave that S in 30. I'll choose Monte Carlo. I'll leave all of these ones. I don't care about this one. I don't have more than 10,000 this thing sample size, so it's okay. Then I'll come to statistics. I'll choose chi-square. You now see how chi-square is. Sometimes we'll do correlation. If the student was saying that to check the correlation between this and this, maybe between HIV infection and intestinal parasite, because correlation also comes in and it has to be feasible also. It's not between correlation between intestinal parasite and gender. That one doesn't really make sense. So when the researcher wants to do correlation, you still do the same thing. But when you come here, you choose what correlations, and there's a way to interpret correlations. So for now, we don't need this other one. We can read all about this. These are deep statistical research or deep knowledge that was done for us by some great men. You can read about what it means by contingency, phi and Kramers. I myself have not read all of this, but at times I go what I want. Lambda, uncertainty coefficient, gamma, Summers D, Kendall's tau B, Kendall's tau C, kappa, Riggs, and Magnemma. These are various tests. Cochrane's and Manhassen's, you can read all of this. If you ever need anyone, just come and add it. You can just check it. If I need Cochrane's and Mantel-Hansel, I'll just check this one. But I don't need it. So no need. I need just my chi-square. I just take my chi-square and I go my way. I take continue. I come to sales. Because I put my result on columns, I will choose column here for my percentages. Very important. Sometimes you can make a mistake here and you go and the results will be rejected and you have to come back. So because I put my result on the columns here, I'll choose columns here. If you need rows, you can still choose rows. Depending on what you want there. You can still choose rows or total here. Give you all of those things. But I need just columns for now. Take OK. Format, I don't really bother much about this. Take OK. Then I will share the output window. When I share the output window, we have a summary of all the variables that we have crossed up with result. And we have seen the number of variables, that's n also. The percentages, case or the missing cases, we don't have any, but luckily, which is great. If you're able to work without missing values, is perfect. So the first one is gender cross tabulation with result. All right, this is the cross tabulation. And SPS will still give you this kind of things that you will not copy this and paste in Microsoft Word. You still need to work on it. So you have the number of males that are positive are 23 of them. And the number of females that are positive are 71. So you can already see that more females are positive with the infection. And for negative, only one male is negative and 7 females are negative. So you can say that more females are what infected with parasite than males. And you focus more on the percentages, okay? So 75% of females are positive. But is this significant? That's a big question. Is it statistically significant? That's when you look at p-value. And again, you never see p-value in SPSS. When you're using R or Python, I think you can see p-value. But SPSS, you will not see p-value. What you will see will be asymptotic significance, two-sided. But there's one thing that will make you to choose what you want to choose here. Normally, we are just normally supposed to come here and pick this Pearson chi-square value. Not so. You pick this person chi-square value, and you're going to put it in your Word document where you have put chi-square value, and you put this one, this is your p-value, okay? It's two-sided. Asymptotic is not exact, it's asymptotic. You can read, those of us who did this thing in school, we know it now. Statistics, where we used to draw that shape that is like a bell, and we'll draw 95% this way, and we say, okay, those one in this dome of 95% is, then we have one side, the other way is two sides. So it gives us two-sided. These things is not coming from the air, it's statistics. So I was supposed to come and take this one. But then you may be wrong. Even though you're doing chi-square test and you have chosen the chi-square value and this one, you may be wrong. Why would you be wrong? Because of this A you are seeing here. A says one cell in bracket 25% has expected count less than 5. The minimum expected count is 1.88. I don't even need to understand this one. But this thing is deep statistics. We're not going deeper into statistics. We're not doing PhD in statistics because you need to understand the chi-square test has some assumptions normally, because it is what a non-parametric test. I think that we will know this one when we get into the course in proper. We'll hear non-parametric test and parametric test. I'm sure you saw this in the course content. So there's some assumptions in the chi-square test which expect that the number, you can read this, you can read more of this, but the expected count that are less than 5 should not be more than 20%. If the expected count less than 5 is more than 20%, then your chi-square statistic is doubt. Is it how they call it? Is doubtful. I don't know if that's the right word to use. It's not very strong. Okay. So once we just look here and see more than 20%, don't pick chi-square value, please. Okay. If you're working with a 2x2 table, what's a 2x2 table? A 2x2 table is when you have two columns and two rows. Like in this case, we have two columns, right? Positive, negative, and two rows, male, female. We don't have a third row. That's a 2x2 table. If you're working a 2x2 table, you just have to come and choose Fisher's exact. So you can choose this, you can put this chi-square value up here. But for your p-value, you are picking the p-value for Fisher's exact, which is 0.67 here. This two-sided, okay. No, don't take one-sided, take two-sided. So it's 0.67, which is not statistically significant. Why? Because we already have a standard that we are using. We're working with 95% confidence or what. So any value that is more than 0.05 is considered not statistically significant. Or in other words, any p-value that is less than 0.05 is considered statistically significant. So you also have to ask the student what they consider to be significant in their research protocol. Because if you don't use what they consider, but in most cases, 99% of the cases, you always use this particular 0.5, 0.05. But in some rare cases, you use 0.01. But I've never really worked with a researcher who wanted to go as far as 99%. It's always 95%. So you see that it's not even significant. So even though we have more females who are infected than males, you cannot generalize it. And we'll do all of this in the course, okay? It doesn't mean that it is wrong. That data, because some people are like, it's not significant, my data is wrong. No, it still makes sense, of course. You still need to give advice to these people, to these women who are living with HIV, maybe in the place where you were testing them. But you cannot generalize this. You cannot infer it. That's called inferential statistics. You cannot infer and say that because I have this value, it means that in the general population, more females living with HIV are more prone to having infection. No, because it is not significant. All right, so you cannot generalize it, but you seek the advice. So that's how you interpret the chi-square. Let's look at age range. Age range is not easy 2x2, so we'll still choose Fisher's exact, even if the count say at 25 at 20%, we'll still choose exact as p-value. So this is a chi-square value 0.4, and the p-value is 0.68. Still not significant, even though I think we have those more than 30 years more infected than those less than 30 years. Then working status is not a 2x2 table, all right? So we have two columns and three rows here. So it's not a 2x2 table, and you will not see Fisher's exact here. Okay, you'll see it, but you don't need it. You need these features exact only when you have 2 by 2 tables. These are rules that you must follow. If you don't follow, you will still have data, but you will not be good data anyway. So what you are going to put here is you're going to you still come and take your expected counts here is 50%. So you cannot take chi-square again. So in this case, since if you don't see Monte Carlo here, you will choose likelihood. So chi-square is not as easy as we think, right? This A here, it defines what you are going to pick on this table. Since this A is more than 20%, and I'm not saying and it's a 2 by 3 table, it's not a 2 by 2. I will not choose exact, I will not choose features exact, I will not choose Pearson chi-square, I'll choose likelihood. Let's see if we have Monte Carlo somewhere. Not yet, but we chose it. All right, no big deal. So you interpret it like this, and then the next thing that we're going to see, or we are going to see in the course, what we're ending here, is how you're going to put the data in Microsoft Word and how you're going to interpret it. That will be the end of your data analysis once you finally interpret it and send it to your researcher. And just know that it might still come back for you to arrange 1 or 2 things. That's why if you are charging a fee for data analysis, you should be able to anticipate that this data might come back to me. And if it comes back to you, you will not tell your researcher to pay you again. So you should have already figured that out you have factored that out in whatever amount you are charging your researcher. All right, I think that was a lengthy one by one person. All right, so this is the end of our demo lesson today. And if you have any questions, you can ask before we discuss on the modalities of the Excel or the SPSS course. And of course, I might have to give the floor, or I will have to give the floor to some S members if they're still here. No, there's no accounts. Queen was here and Madrid, but as maybe due to network issues, they have disconnected. All right. We have Mr. Chewy here, of course. He's one of us. All right, so over to you. If you have any question or an appraisal, please, you have the floor. You can unmute your mic and speak if you have anything. Maybe you have a question. You can unmute your mic. Yes, Mr. Shinyako, your mic is on. I don't know if you have something to say.
Well, actually, is that I've learned just